Lists in Python are an important data structure used to contain multiple items. To create one, simply use square brackets. Items in the list are separated by commas. And unlike Java, multiple different data types can be stored in a single list. For example, this list is composed of 3 integers and a string. Additionally, unlike Java arrays, these lists in Python do not have fixed sizes. To reference specific items in the list, use its index. The first item has index 0, the second item has index 1, and the third item has index 2, etc. You can also use negative index. So for example, index -1 would give you the last item in the list, and -2 would give you the second to last item in the list. To add an item at the end of a list, use the append method. To insert the item at a specific location in the list, use the insert method, with the first parameter being the index and the second the item. To delete a specified value from the list, use the remove method, passing in the parameter of the value that you want to be removed. If there are more than one occurrences of this value, the first occurrence will be deleted and not the others. To remove a specific index from the list, use the pop method. For example, passing the parameter of index 0 would delete the first index of the list, and changing the parameter to 1 would delete the second index of the list. To get the index of a specified value, use the index method. Pass in the corresponding value to which you want the index of. If there are multiple items with the specified value, then the index of the first occurring item with this value will be returned. However, you can also specify which occurrence of the item you want to get. So if you pass in 2, you will get the index of the second item, which will be 4 in this case. To get the number of times a specified value is in a list, use the count method. For example, there are 2 2s in this list, or 1 3 in this list. Additionally, the sort method can be used to sort the list numerically if the list contains only number items, or alphabetically if the list contains only string items. As you can see, it is now sorted from lowest to highest. The same works for strings. As you can see, the string list is also sorted alphabetically. Additionally, the reverse method can be used to reverse the order of the entire list. So now it is in reverse alphabetical order. However, if we undo the sort, you can see that it is just the reverse of the original list, where orange used to be the first index but now is the last index. 2 lists may also be joined together via the extend method. So the second list is added at the end of the first list, as seen here. To delete all items of a list, the clear method can be used. As you can see, the list is now empty. The last method for lists is the copy method. The copy method creates a duplicate of the list. This may seem trivial, as you may be tempted to simply assign test list to this new list. However, when you do this, you're not actually creating 2 distinct lists in the memory. Instead, test list and new list are essentially sharing the same memory address, which is pointing to this singular list. This means that if I edit new list, then the test list will also be edited with it, because this list exists in memory and is basically shared by these 2 variables. However, when I do the copy method and create a duplicate of the list, as you can see, test list is no longer affected by changes to new list. And if you print new list is still clear. Now let's cover iterating over a list. There are two methods to this. The first I'll show you is iterating by directly referencing each item. Now to do this, let's pretend that this list is a list of students' grade on a unit test. And to do this, we're going to use the command word for, and then grade in grades. And then, as you can see, it will print each item individually. Now, this is useful when you want to directly access each item. For example, if you want to find the mean grade of students on this test, you can just iterate over each grade and add it to the total, and then you can print the total over the size of the class. However, the downside to this iteration method is that you don't know the index in which you're referring to. You only know the item value itself. So it wouldn't be good, for example, if you wanted the index of all students who got over a 70 on this test. For that, you would want to iterate via index. So how you do this is for I in the range of the length of the list. And basically what this is doing is iterating the index from 0 all the way to the size of the list, so 9. And so now you both have the item itself and the index. So if I wanted to say get all the students index who are above 70, I could simply check if grades index is greater than 70, and if that's true, we can have a list called students, and we can add our index to it, and we can print this out. And as you can see, this is a list of the index of all students who got over 70. Now we can use both iteration methods to effectively traverse a 2D list. So here is an example of a 2D list, and there's 3 inner lists, and right now each of them are representing a class period. And so what we can do is we can first loop through using index the outer one, and by doing this it'll print all 3 inner lists. Now what we can do is we can traverse through each of the inner lists using our first iteration method, which directly accesses the items. So for grade in the list that we're traversing, and we can just print the grade. And as you can see, it now prints the individual items in each list. The last thing I'm going to cover is mapping, and mapping essentially performs a function on all individual items of the list. For example, if we wanted to turn all of these integers into floats, we can do this by mapping, and then the first parameter is the function, so float, and the second parameter is the list that you're performing the function on, grades. And when we print this, it prints as a map object, so we can turn it back into a list. And as you can see, we now have the floats. We can also turn this list into strings. Furthermore, we can also do our own operations. And to do this, we can use the lambda function. So the keyword is lambda, and then followed by whatever parameter you want to name. So let's say x, and then let's say 2 times x is the function we want to do. So now each item in the list is doubled. Or if we want to square each item in the list, we can do x times x. And again, this x is just a variable name, so you can change it to like I, as long as you change everything else to I. And so mapping can be really useful for quickly transforming lists.